Welcome to myprojectbazaar.com. This is the paper title of our project called Epidemic Attacks in Network Coding Enabled Wireless Mesh Networks Detection, Identification and its Evaluation. This is the abstract of our discussing project. Here, the network coding has emerged as a new communication paradigm that can significantly improve the efficiency of the network protocols by utilizing its intermediate nodes, which mix up its corrupted packets before forwarding them. Thus, corrupted packets propagate in an epidemic manner, that is, in a repeated manner, which depletes the network resources and also significantly reduces its throughput. Thus, in this paper, we have addressed the main problem of collision attacks against the network coding systems in wireless mesh networks. Thus, we have proposed a novel and computationally efficient security algorithm which referred to as null keys to detect malicious attacks based on the random linear network coding. This diagram represents the overall data flow of this project. After the node deployment, we just start calculating the node's positions for the deployed nodes. And then we have to select the source and the destination node among the deployed nodes. Finally, the source node will select a file or encrypt the selected file into the packet splitting. Now, we have to generate null keys for each splitted packets using its hash function. Now, these splitted packets along with the null keys will get forwarded to its forwarding nodes. So, forwarding nodes will be selected with the use of the randomized approach. Here, once the forwarding nodes receive the encrypted packet along with this null keys, it will also generate a null keys for this received encrypted packets, and it gets matched with the forwarded null keys. Once the null keys gets matched of this corresponding packets, it will further forward it to the destination. Otherwise, the nodes will itself discard all the mismatched null keys packets. Now we can start looking for the demo of this project from the title page. Now I have to enter the number of nodes to be deployed here randomly, and its positions will get updated. And then we have to update the deployed nodes, and among the deployed nodes I have to select any two nodes as its source and the destination node, and its positions will be displayed in here. Now the Euclidean distance formula's description is shown here. Now I have to display the selected source node and the destination node ID to start calculating distance between the source to all other nodes in here. And now the source node will select a file for packet splitting, and its corresponding contents will get displayed in here. Now the selected files informations will be displayed, and now I have to enter a new name for the packet splitting. Now I have to enter a number of packets to be splitted. Once it is splitted successfully, I have to start encrypting each packets in this form. I have to select first packet and will encrypt it in here until the last packet. So now we have to start generating a null keys. So by loading this files, we have to select the folder name which contains the encrypted packets, and now each encrypted packets will be stored in the name of encrypted 1, 2 and 3. Now I have to select each encrypted packets, and I have to generate a null keys for each packet. So this process gets repeated until the last packets, and then I have to start looking for the forwarders using this randomized approach with the help of this each node's success rates. So here I have to just extract this deployed nodes and this corresponding success rates of each nodes in a probabilities values. Now the forwarder selections will get started from the nodes ID and the success rate and its failure rates. Now for the optimal forwarders, I have to get the threshold values for our success rates, and all the nodes successful will get tuned above this threshold values. So among these nodes, I have to select the optimal forwarders by just ordering its nodes success rates from maximum to minimum. So then I have to update these optimal forwarders again to the senders to proceed with the packet forwarding. So now I just update the topmost 5 optimal forwarders. Now I can select any one of the forwarding nodes randomly and then select any encrypted packet and get its key. Now I have to forward the null keys and its encrypted packet to its selected forwarding node using this port numbers. Initially I have to send this key to this forwarder, then I will start running this forwarding node 1 form, and I have to use the same port numbers and will get the key. Once again I have to send this packet and gets received in the selected forwarding node, and then I have to generate the null keys for this received encrypted packets. Once it is get matched, it can be further forwarded to the destination, otherwise the packet cannot be forwarded to further. So from forwarding node I have to send this packet and its null keys to its destination. So using this port number I am just forwarding these packets to the destination. So run the destination form to receive the sent file. So first get this key and again forward this packet, and it gets received in the receiver form, and generate a null keys and verify it. Once it is get matched, again we have to start the second packet forwarding. That is here we got an acknowledgement for the first packet, and now I'm just selecting a second forwarding node and second encrypted packet and gets its corresponding null keys. Now use the different port numbers and it will get forwarded to the second forwarding nodes form. Use the same port numbers and get the key first. Again send its packet and receive it in the second forwarding node. Now generate the null keys and verify it. Now use the different port numbers and again forward these packets to the destination again. Now change the port number, get it keys, and again forward the packet to receive at the destination. Receive this packet, generate its key, verify it. Now after the successful second packet delivery, now we have to change the forwarding node's ID and its packet. Now get its corresponding selected null keys packet. Now change the port number. Now start running this third forwarding node. Use the same port numbers and get the key first. Now just forward the packet and receive it in the third forwarding node. Now generate its null keys and verify it. Use some other port numbers and forward it to the destination. Here use the same port numbers and get the key first. and then again forward the packet and receive the packet and generate its null keys. Once it is verified successfully, we can just start merging all the received packets. So received packets list will be displayed in here. Now we have to reorder this file list. Now I have to select each encrypted packet to decrypt it. So I'm just first selecting the first encrypted packet and just decrypting, and second one to decrypt it, and third one to decrypt it. And once all the packets gets decrypted successfully, it is merged to get the source file. So finally we get the source files packet. Now we can start evaluating its performance. Here we have taken the time complexity for file transmission among the existing and proposed method of checksum and null keys, and its packet throughput graph is also displayed in here. Thank you for watching this video.